without further ado, we'll get on with this one. So, not going to take too long, this one, I don't think. We're just going to take you through the various structural deck types that we find out there when we're surveying flat roofs, and then take you through a few live kind of examples of core samples, the kind of materials you're likely to see when you're surveying roofs, and obviously the ones to kind of avoid, because there are some structural decks out there that we really shouldn't be that we shouldn't be overlaying and things like that when we're surveying these roofs. Okie dokie. Get the slides to work. There we go. So yeah, I'm not going to harp on too much about me. If you've seen the other two sessions, you know who I am. Hopefully you've seen me on LinkedIn jumping all over roofs and things like that. Obviously not chipboard roofs, which you'll find out why in a minute. So the first things first, really, just got to highlight this. We all want to go home to our families. We all want to go home to our children. So if you do find a structural deck out there, and we'll show you how you're going to do that, that's fragile, you shouldn't really be working on, don't go on there. Don't endanger yourself. First things first, as we know when we're working at heights. You see the falls from heights there is the biggest killer when it comes to the construction industry. So make sure that you're safe, make sure that you're staying away from the edge and all that kind of thing. Make sure that if you do a core sample and find that it's a fragile deck, tiptoe off the roof as quickly as you can. Okay, so the main structural deck types that we're going to see in the UK, because more in the common and more modern construction are timber, metal and concrete. They're the three that we're going to see in modern construction. However, we'll go through, there are some others that you might find from historic buildings when you're doing your core samples. Just a quick reminder as well. I know we did this in a previous session, but there's three types of flat roof constructions out there: warm roof, cold roof, and inverted roof. So when we're doing core samples, that's the kind of things that we're going to consider. So when you on a warm roof, for example, likely to be waterproofing, and then measuring the thickness of the insulation. Is there a vapor barrier in place, and what's the structural deck? If it's a cold roof, we should be trying to establish that from internally before we go on the roof. But then obviously if we take an area of waterproofing out, find that there's a timber deck there, we need to find out if that's been overlaid or whatever. Possibly need to drill through that timber deck to see that it's not a warm roof that's been overlaid. An inverted roof is fairly obvious. When you step on the roof, you're going to see paving slabs, you're going to see ballast and things like that. Wouldn't kind of recommend core sampling these roofs if we don't have to. They are usually over a concrete deck, and we can usually establish that from inside the building before we step on the roof. So they're the kind of three areas. So onto the deck types. When it comes to timber, various types of timber out there that we see as structural decks. Plywood is one of them. A wide range of plywoods out there, generally 18-19 millimeters thick. When it comes to roofing grade, should be external grade as well. Can be down to 15 millimeters. Depending on the closeness, if the supported structure is closely spaced enough, all that kind of thing. But obviously, when you're taking a core sample, looking for that timber, that plywood deck, it's fairly obvious. You'll have seen plywood in your normal kind of day-to-day DIY stuff, so you should be able to recognise the plywood on a deck. Like I say, you can see it from underneath as well as from on top when taking core samples. OSB is another one that you come across. It's more common these days with a roofing deck. Different types of OSB out there. OSB 3 and OSB 4 are the ones that we should be looking for when we're specifying a new build, for example, or a strip and replace. So OSB 3 as a minimum. These are generally, like say, 19 millimeters, 18, 19 millimeters thick. They can come in tongue and groove profiles and things like that. And now onto the kind of less common these days timber decks that we see. Close boarded timber decking was more common back in the 80s, 90s, when there was a pour and roll system out there for felt. They used to nail a layer of felt first, and then bond the underlay to that nailed layer, just to stop the bitumen from going through those gaps there that you can see. So, like I say, when you're doing a core sample, it's not uncommon to come across this and see that there's a nailed layer in place that you can easily remove. Like I've done in this image, it's more likely that you're going to identify a timber boarded deck from the bottom, because obviously if you're doing core samples from the top, all you're going to see is joints and planks, really. So it's more difficult to identify a close boarded deck unless you really know what you're looking for. But like I say, it's always better to go underneath first and see what the deck is from the underside. A, to determine what it is, and B, to determine whether it's safe to traffic. So the other kind of timber deck, again, don't see that often these days. This is chipboard. This is deemed on the HSG 33 and the health and safety guidance. This is deemed as a fragile deck. So every time we come across this, we should be saying to strip and replace it. When it becomes wet, it becomes very fragile. And if you see it from the underneath, really, my advice really should be not to traffic the roof, because it needs to be stripped, really. But if you come across it from the top, and if you couldn't see it from the underside when you're doing a core sample, which we do from time to time, obviously sometimes you can't see the underside. So the only way that you're going to know it's a timber, it's a chipboard deck, is by taking that core sample. Like I say, just be very careful, because especially in areas where there's been water ingress, because this stuff really does go like Weetabix and can be structurally unsound if you're trafficking the roof. Okay, so onto concrete. Like I say, structural concrete decks are reinforced, precast, block and beam, and then there's lightweight aerated screeds that can go over the top, usually to create a fall. When it comes to casting the concrete in situ, shuttering is usually metal shuttering. In the olden days, we did see woodwool slab sometimes used as shuttering as well. So it's not uncommon to do a core sample and you come across a concrete deck, but then you look from the underneath and you see woodwool. That's because woodwool was used as shuttering for concrete decks once upon a time. But that's your reinforced cast in situ. You see the rebar there in place. Precast is exactly how it sounds. It's craned onto the roof and then put in place on the roof, the joints sealed and all that kind of thing. And then you've got block and beam. Again, this is more of a historical kind of construction. You've got concrete beams and then blocks inside, blocks that you can see from the inside there. So that's what's classed as a block and beam concrete roof. So moving on to the last one now is the last one used in modern construction, I should say, which is a metal deck. These are usually used for speed and lightweight, usually used in conjunction with a mechanically fixed system, whether that be, and the most common one of those is a single ply. So when you're looking from the underside, it's not uncommon to see fixings protruding through these metal decks. And then obviously when we're taking a core sample from the top through the single ply, through the insulation, you'll usually see a visqueen type vapor control layer used on these roofs. There are others as well. Obviously you can bond to these roofs. The VCL can be bonded to these roofs as well, to these decks, let's say. So, but obviously the deck needs to be specified so that you get at least a minimum 45% bond to the areas. So the troughs and the crowns need to be correctly specified. So now there's less common ones, obviously, that we don't tend to see in modern construction these days. They are woodwool slabs, stramit or strawboard are the one that was in the news a couple of years ago now, is RAAC, or reinforced autoclaved aerated concrete. So woodwool slabs can be confused to the kind of untrained or less experienced eye with a stramit deck. We do get asked the question quite often: is this woodwool or is this stramit? Easiest way to determine that. This one's been painted, by the way. This isn't what a woodwool slab would look like. It's more of a brown finish like that. This one's been painted, but you can see the random kind of way that the strands of the wood shavings are present in there. When it comes to stramit or strawboard, it's usually in a line, or less random than that, and it looks more like straw or hay that you will see on a roof. And we've got some pictures of that in a minute. Two types of woodwool. Channel reinforced, like that one is there, which has got your channels there and everything like that. If it's dry, it can remain in situ. If it's been wet, as this one is, it can still be okay if the areas are okay. If it's been saturated, then sometimes you'd need to strip it off. Difficult to mechanically fix into woodwool slabs. So if there's any areas that you need to consolidate, difficult to do. Would recommend pull-out tests by the fixing manufacturers and things like that. So channel reinforced, like I say, different kind of finishes of woodwool slabs as well. Paper faced, pre-screeded woodwool slabs. So sometimes you'll come across a concrete screed and then you'll dig down a little bit further and you'll find that it's woodwool. That's a pre-screeded woodwool slab. The NFRC have put quite a good guidance note together on woodwool slabs and whether to replace them, whether to overlay them. So I'd recommend having a look at that. And that obviously is not channel reinforced. So that's just where the woodwool slabs are installed over timber bearers in this instance. So they are not channel reinforced. So this is your stramit board. This is one that's been stripped off and put in a skip. So you can kind of see why it gets confused with woodwool slab. Can look to a less experienced person similar to woodwool slab, but they are starkly different when it comes to their fragility. This stramit or strawboard, if you come across it, should always be stripped. And it is deemed as a fragile deck under HSG 33. How to recognise that? So from the bottom, you can sometimes see, like I say, from the underside, you can sometimes see it just looks like hay or straw that you will find. It is literally straw. And from the top, more yellow in colour if it's dry, more yellow in colour than a concrete deck. And you can see the straw there. as I say, if you're not able to see it from the underside, and you do a core sample on this, obviously be careful. If you come across this, this is a fragile deck. RAAC, lightweight form of precast concrete, was frequently used in the public sector buildings from the 1960s to the 1990s. There was a lot of press coverage on this a couple of years ago, so it can be it can look like a precast concrete, but the span or the width of the planks is different. They're usually around 600 wide. It's less durable than traditional concrete, and problems can result from that with safety, stuff like that. You will have seen that in the news. Thing is with RAAC, if it's suspected, then my advice as a surveyor is an assessment needs to be carried out either by a structural or chartered civil engineer, and they have to be familiar with the assessment of reinforced concrete structures. The government did put out an advice paper on it and everything, so have a read of that. Like I say, it was heavily covered in the news, so it's not worth me going on about it. Like I said, this is a RAAC checklist that was put out by RICS. RICS have put more guidance out on this since I put this presentation together. But when you're looking for RAAC, like I say, 600 wide concrete planks, they have got V-shaped grooves. If you can see that at the edges, and obviously look at drawings and things like that. Again, if you do a core sample, that tends to be what RAAC looks like when you're doing a core sample. What I tend to do is, if I find something soft, is carry on with caution to see if it is maybe a pre-screeded concrete deck, maybe it's a screeded woodwool slab. If you do keep going and dig this out, then obviously just be careful and make the client aware that it's suspected as a RAAC deck, and you need to get the right kind of advice on there from the right kind of suitably qualified people. So that's kind of what it does, what it looks like if you're taking a core sample from the top. So what can we do with RAAC is that, again, this is advice from others. We can leave it and monitor it, prop it up, give end bearing support, full span support, replace or demolish. But like I say, get a suitably qualified person in if you're doing your surveys to make sure that you're coming up with the right remediation. I think that the heat has been taken off the RAAC decks lately, but obviously one that's worth bearing in mind. So, like I said, we've come across this. We've gone across this checklist before in sessions 1 and 2. Now we're looking at the condition of the existing deck. Those are all the other things that you should be looking for when you survey a roof. So the condition of the existing build-up, including the roof deck, core samples. Like I say, wherever possible, look at the underside of the deck first before setting foot on the roof. A bit of a live example here. So you've got your ceiling tiles there. If you've got suspended ceiling tiles, remove one of them, have a look inside, because if you see something like that, then really you shouldn't be going on that roof. Like you can see there, you've got a chipboard deck that's saturated because of that water ingress. This again, profiled metal deck that's obviously had water ingress over time, over an extensive time period. In this example, caused the metal deck there to corrode. So again, just caution if you're going to traffic these roofs. Like I said, we all want to go home to our families. Okay, so core samples. Going to go into a few kind of live examples here of core sampling kind of decks that we see, the kind of insulation that we see, and the kind of purpose of core samples. So they tell us the type, condition of the complete roof build-up. For me, they are essential when it comes to conducting a roof survey, especially if you want a thorough roof survey where we're putting together the recommendations at the end of it. We need to know the thickness of the insulation so that if we're overlaying more than 50% of that roof, we're complying with building regulations to say whether it needs a thermal upgrade or not. So again, when taking core samples, it's important to know that we've reached the structural deck. Sometimes things have been overlaid, especially when it comes to kind of rigid GRP systems. So a rigid GRP overlay system has to go on a timber deck. So in order to do that, they sometimes will put battens down, put the timber deck over the top of the existing, and then put a rigid GRP system over the top. So especially if you're seeing a liquid system on there, and you take a core sample and you come to the timber deck immediately, then obviously we need to core through that deck and see what's underneath, because there might be something underneath there. We should always consider taking several core samples, because a roof build-up might be different on one roof or across a large area of roof. It can be different. It could be the roof could have been extended, the building could have been extended, so we might get different varying thicknesses, varying types of insulation on there. And also we need to determine whether tapered insulation is on there as well. We've got a picture of tapered insulation. So teaching grandma to suck eggs, but tapered insulation is thicker at one end than it is at the other end, so thinner to thicker. So what we don't want to do is strip that roof off and put a flat board on there, and then we'll have a nice area for the birds to have a bath in, and we don't want to do that. So if there's tapered insulation on there and the roof needs stripping, we need to make sure that we're reinstating tapered insulation. So we need to find out whether it's tapered from taking several core samples. So in this instance, like I say, going to go through a few examples now of core samples. This one's a single ply roof. You can see the adhesive on the back of the single ply there. We can see that it's polystyrene. So this is expanded polystyrene insulation. Awful stuff if you come across it. Hopefully you're not squeamish when it comes to unpacking your TVs and things like that, because this is exactly what that insulation is. Dig through it with gritted teeth, and we find now that we've got a visqueen vapor control layer there in place, and we've cut that open and we see we've got a plywood deck. Take a measurement. We always need to take a measurement of the insulation. So you can see that's quite thick in this area, 170, 180 square meters. So then we'll say to ourselves, well, that is quite thick. So is it tapered insulation on this? So a couple of ways of determining whether it is. Take a core sample at a low point, or you can use something like a long screwdriver to pop in there. Obviously, we need to patch these areas up if we're not taking, even if we're not taking core samples, and we can see that it's 90 millimeters to 100 millimeters near the gutter there. So we know that in this instance that is tapered insulation. I say just an example of tapered insulation there. You can see on the left hand side, the insulation is thicker on the parapet wall edge than it is on the other edge in that section. And on the right hand side there, an example of a tapered insulation layout. This is mitered in this instance to redirect the water to the outlets there. So again, just a few kind of examples I'm going to run through now with you. So maybe this one to the untrained eye might look like an EPDM single ply with some insulation, concrete deck. But we always need to if we're destructively testing, we need to scrape that concrete or whatever it is. And when we've done that, we've actually found out that it's actually asphalt. So we obviously then need to establish what's beneath the asphalt. Is there more insulation in there? We're going to be doing U-value calculations, condensation, risk analysis, everything like that. So what's beneath the insulation, the asphalt? In this instance, you can see that you've got a timber deck there, likely timber boarded in that instance. So like you say, we can see as we look down there, it's a timber deck. This is what we were talking about, an example of a rigid GRP system. So you can see the top surface there. They've overlaid that with an OSB board, which we've cored through, and you can see there that there's chippings. So that's obviously a felt roof or an asphalt roof that's got chippings on the top. So we need to remove a larger area now and take a core sample then of that deck below, so that we can do the right U-value calculations. We can do the right condensation risk analysis to make sure that we're putting forward the right specification for an overlay on that roof. Does the GRP system need to come off? Is it causing interstitial condensation? All of that kind of stuff. So a bit of a progressive one here. So we've taken, this is an aged felt, as you can see there, likely a polyester oxidized felt system. We know it's a pour and roll system, because like I say, we've gone through it on the previous ones, but we see about the bitumen bead there and that the laps have been watered. But we can also see on the back of that sample, there's a hole there in the felt. That's what's called a 3G. It's, like I say, holes in that layer of the felt. So what happens is that layer is loose laid on top of the insulation to allow the insulation to breathe. So the 3G layer with the holes in it is laid. Then hot bitumen would have been mopped over the top of that. The bitumen would go through the holes to form a bitumen rivet, for the want of a better description, and then the cap sheet, the underlay and cap sheet, would go over the top of that, so that any vapor that's in the system, any gases or anything that are coming from that insulation won't cause a blister, because if you fully bond anything to a permeable substrate, it can blister. So that's the way that they got around it in the olden days, was to put a 3G system, mop the bitumen on top, and then lay the system over the top, so that the system wasn't actually fully bonded to the insulation. So we'll dig down a bit further here. You can see the underlay, or the top surface of that fiberboard system there, and underneath that fiberboard, what we can see there is a chipboard deck. So again, taking some moisture readings, which is what I always do with the core samples. Just use a protometer to take some moisture readings, just to give that evidence to the client that in this instance, obviously it's actually dry, this chipboard deck, but it's still chipboard. So under HS health and safety guidance, we should be stripping that off. This one, we can see we've got a concrete screeded deck. We've got a vapor control layer. We've got around 30 to 40 millimeters of PIR or PUR insulation, and then a built-up felt system on the top of that one. This is a liquid system. You can see around the side there, we've taken an area out here. This is more modern PIR insulation. You see an example of that. This one is an asphalt roof that we've cored out, and then underneath that we've got rock wool insulation. In this instance, you can see it's wet because of the colour of it and everything. So yeah, so that's another kind of example of what you might find. So rock wool insulation has become more and more popular these days in the advent of approved document B, where obviously fire becomes more prevalent these days, and this insulation is completely non-combustible. So we have seen an increase in the sales of the how common we see hard rock and rock wool insulation being used. This is one that we don't see much of these days. Cork insulation isn't produced anymore. The manufacture of cork ceased in around the late 90s, just because of the cost of it. Really, it was, and one of the reasons that cork was introduced is that you could fully bond a bitumen system to cork because the cork is inert, therefore it doesn't gas, so it doesn't blister. So, like I say, back in the olden days, cork used to be used on sloping roofs greater than 10 degrees and on vertical upstands as well, because the felt could be fully bonded, which it needed to be, obviously, on vertical surfaces and things like that. So you see cork was used. You could also cut cork to any profile as well, so it was really handy back in the days when I used to design tapered insulation systems. Really handy to use cork sometimes where a slight fall was needed, or where more of a fall was needed as well, because like I say, cork could be used in those instances. It was a really kind of diverse product. In this instance, this is a lot darker than its original form because it's wet in this core sample. It can also look like that as well, literally like your cork kind of bath mat, your cork wine cork just looks exactly the same as that when you're taking a core sample. There's also composite boards that you might find out there. So I haven't got a live example of this, but you might find a cork composite board where 20 millimeters of cork was bonded to the top of a PUR board. That was because the PUR had better insulative properties, but you could fully bond to the cork. So that was something that was around in the 80s, 90s, was a cork PUR composite board. So you might dig down through the cork, and you always should, to find out what depth it is, and you might find PUR underneath it. This is also a composite board. This again was done for the same reasons. Reasons of cost in this instance, because the polystyrene that we can see underneath here is a cheaper kind of insulant alternative, but the fiber board was there so that you could actually bond to the polystyrene. Obviously, polystyrene melts if you put anything hot on it, so the fiber board was bonded to the top of it so that the felt could either be torched onto it or pour and roll onto the top of the surface without damaging the polystyrene underneath. So you might find a fiber board which is 13 millimeters thick, and then your polystyrene underneath. So again, fiber board, polystyrene composite in that instance. Just a few more pictures of it there. Some less common things that you might come across. This is what's called a LITAG screed or insul screed. If you Google it, you will find it. For me, it looks a bit like sheep droppings. If you dig it out, it's there as an insulation. Like I said, it is called insul screed, and it's also there to provide falls as well. Say that's just something that you might come across. Would probably always recommend to strip and remove that these days and put a tapered insulation system back down in its place. This one, again, less common, is what's called vermiculite. And so this is, again, something that was used to create falls in there. It's what's called a vermiculite screed, usually found over concrete. Again, in this instance, it's saturated. So we'd strip this out and replace it with tapered insulation. Okay, so relevant documentation that I always put at the end of these presentations, the kind of the go-to thing for flat roofs is BS 6229. 2018 was the latest version of that. It is being looked at the moment. BS 5250 is the one that deals with your condensation. And then you've got approved document L, which is your building regulations for insulation. And we should also add on there is approved document B now, which comes with your fire and says about the systems needing to be approved to B roof T4 and all that kind of thing. Okay, I told you I won't keep you too long today. It's only a short one. That we do have other courses available if you want me to present to your practice or anything like that, face to face or online. Get in touch if you want a CPD. And if you don't want to take the core samples yourself, fully kind of understand that, but it's something that obviously we can do for you as part of our service. So we do offer full condition surveys, all of those things there, specifications, drawings, reports, project management services, everything like that. So I'll just leave my contact details on the screen for you there.